Hello students, we have been seeing the chapter Metallurgy. Let's revise what we have studied in the previous class. So we have started with the extraction of metal from ore. It includes 3 steps: concentration of ore, extraction of crude metal and refining of crude metal. So in that we have seen about the first process, that is concentration of ore. It has 4 methods: gravity separation or hydraulic washing. It is the first method. Here the principle is based on the specific gravity. And second, we have seen about froth flotation. Here the principle is based on the wetting properties. Then we have seen along with the examples. Then third, leaching. Here it is based on the solubility property of the ore. In that there is a 4 types: cyanide leaching, ammonia leaching, alkali leaching, acid leaching, and we have seen examples for each cases. Then at last we have seen about the magnetic separation. Here the principle is based on the magnetic properties of the ores. So this is the first method, the concentration of ore. Now today's class we are going to see about the second process, that is extraction of crude metal. Here crude metal means it is something a solid mass from which we are able to separate the pure metal. Here this extraction of crude metal is carried out by 2 steps. It's a major step. First one is conversion of ore into a metal oxide. It is a first step. Then after converting into metal oxide, the second step is reduction of metal oxide into its metal. This is the second step. So students, first one is ore converts to metal oxide by oxidation process. That is first step. Then metal oxide converts to metal by reduction. This is the second step. So as you all know, oxidation means it's an addition of oxygen or removal of hydrogen or loss of electron. And reduction means removal of oxygen or addition of hydrogen or gain of electron. So this specific definition for oxidation and reduction can be vary for every type of reactions. So based on the reactions we can use oxidation and reduction. Here, the concentrated ore, generally the metal will be exist in the positive oxidation state. So based on the oxidation and reduction reaction, we have to convert the concentrated ore into its metal. So we are using some oxidizing agent as well as the reducing agent. How we are choosing this? That is based on the thermodynamic principles of metallurgy. Here, the reduction of oxide is easier when compared to the reduction of other compounds of metal, which means first there is a ore, we have to convert into metal oxide, then we have to convert metal oxide to ore. ஏன் நம்ம மெட்டல் ஆக்சைடை ஃபர்ஸ்ட் ஸ்டெப்ல கன்வெர்ட் பண்றோம் அப்படின்னா ரிடக்ஷன் ப்ராசஸ்க்கு ஃபர்ஸ்ட் அது மெட்டல் ஆக்சைடா இருந்ததுன்னா அது ஈஸியா ரிடியூஸ் ஆயிரும் மெட்டலா. தட்ஸ் பை in the first step we are converting the ore into metal oxide. So hence before reduction ore has to convert into its oxide. So adukku 2 methods are there. One is roasting, then second is calcination. So 2 methods we can use. So first let us know the difference between roasting and calcination. You are able to see the picture, 2 different types of picture. One is fish is getting roasted and one more picture with a pressure cooker. So look at the picture 1. Here they are roasting the fish. So how they are doing the process? In the down they are giving the heat. So they are giving first we have to give heat. Then it is roasting in the open air. So அதுக்கு மேல some oxygen or some air வந்து சப்ளை ஆகிட்டே இருக்கு. கீழ என்ன கொடுக்கிறோம்? ஹீட் கொடுக்கிறோம். So this is the roasting process. இப்போ எப்படி ஒரு ஃபிஷ்ஷை ரோஸ்ட் பண்றோமோ அந்த மாதிரி ஒரு மெட்டல் எடுத்து நம்ம ரோஸ்டிங் பண்றோம். என்ன கொடுக்கணும்? ஒரு மேஜரா அதுக்கு ஹீட் கொடுக்கணும். Then it has to be in the presence of air. That is only roasting. Here calcination ana, look at the second picture. Here the pressure cooker. So pressure cooker ku நம்ம கீழ we are giving the heat. But here we are closing the lid. அப்பனா இங்க இதுக்குள்ள என்ன போகாது? Air flow இருக்கவே இருக்காது. So here there is no supply of air or oxygen, but we are giving heat. So இதுதான் major difference between roasting and calcination. Roastingல என்ன பண்றோம்? We are giving heat then in presence of air. But in calcination we are giving heat but in the absence of air. So this is the major difference between the roasting and calcination. So roasting, it is exclusively used for the sulfide ores. அப்போ அதோட impurities வந்து எப்படி ரிமூவ் ஆகும்னா, it removes as a volatile oxide as sulfur dioxide. Sulfide ore யூஸ் பண்றோம், அதோட அதோட impurities வந்து sulfur dioxide ரிமூவ் ஆகும். In calcination we are taking for carbonate ores. Carbonate ores எடுத்து தான் நம்ம calcination பண்றோம். அப்போ அதுல உள்ள impurities எப்படி ரிமூவ் ஆகும் as a carbon dioxide. And one more case is, ore is heated below the melting point in the presence of air or oxygen. We have already seen. Ore enna pandrom? Heat pandrom, but the heating should be below the melting point of the metal. So this is the condition here. We have to heat the ore below its melting point of the metal in presence of air or oxygen. But in calcination, the same condition. Ore has to be heated below the melting point of the metal in the absence or limited supply of air. Sometimes it is completely the absence of air, or sometimes we need some air for that. So we have to give limited supply of air. So this is the process of calcination. So let's revise. For roasting, we are using sulfide ores, and for calcination, we are using carbonate ores. And this and the impurities has to remove as sulfur dioxide in roasting, and in calcination, impurities has to remove as a carbon dioxide, because we are using the carbonate ores. And in roasting, ore has to be heated below its melting point in the presence of air or oxygen. In calcination, ore has to be heated below its melting point in the absence or limited supply of air or oxygen. First, roasting. So these are the points we have already seen. In roasting, what we are doing is we have to convert the ore to metal oxide. So for that, first we have to heat the ore below its melting point with the excess supply of oxygen in the suitable furnace. Here furnace means it's like a heater or a boiler, and thadukulla we are doing this roasting process, and it is applied for conversion of sulfide ores into its oxide. Sulfide ore adoda metal oxide convert பண்ணுது. Then here impurities has to be removed as a volatile oxide. Volatile na enna gas remove ஆகும். So நம்ம sulfide ores use பண்றோம், it has to remove the impurities as sulfur dioxide. So we have seen the roasting is exclusively for sulfide ores. Sulfide ores nale by default you have to remember galena and zinc sulfide. So we have taken the example of galena and zinc blend as a sulfide ores. So in the process what we are doing is metal sulfide edukrom, then adula in presence of oxygen we are heating. Here this triangle symbol refers to heating process. So we are heating metal sulfide in presence of oxygen in the suitable furnace. Furnace means the heat pandra the boiler pero illa the heater pero, we call it as furnace. So we are heating this, and at the end of the reaction we are getting the metal oxide along with the impurities sulfur dioxide, and it removes as a gas or vapor. Look at the equation here. We have taken galena PbS, along with that it reacts with the oxygen 3O2, and we are heating. Here this triangle represents a heating process. So heat பண்ணும்போது lead oxide மாறுது, means it converts into metal oxide, along with that 2SO2 removes as a sulfur dioxide. It's a volatile gas. Then next we have taken zinc sulfide, zinc blend ZnS in presence of oxygen 3O2. We are heating in the furnace, and at the end of the reaction we are getting zinc oxide. This zinc blend converts into zinc oxide, means it's metal oxide. Along with that sulfur dioxide removes as an impurity. Then one more thing they are taking, copper glans Cu2S, copper glans. This is also a sulfide ore. Along with that it reacts with the oxygen, and heating it gives Cu2O plus 2SO2, which means the sulfur dioxide it removes as an impurity. So whenever the process happens, it removes some impurities. So roasting la, along with the roasting there will be some other impurities also will be there, like arsenic or sulfur or phosphorus. It may be anything may be there. So அந்த எல்லா impurities-உம் oxygen-ஓட சேர்ந்து அதோட volatile oxide தான் release ஆகும். From the equation we have seen sulfur என்னது sulfur dioxide it will release. So if it is arsenic present in there, arsenic அதில் present இருந்ததுன்னா oxygen-ஓட சேர்ந்து it removes as a arsenic oxide. In the same case goes to phosphorus. Phosphorus வந்து it reacts with oxygen and it removes as phosphorus pentoxide. Here sulfur dioxide removes as a gas. It creates a harmful to the environment. So you have studied about acid rain and all. Acid rain, then depletion of ozone layer, greenhouse effect. So இதுக்கெல்லாம் major causes என்னன்னா இந்த sulfur dioxide வந்து environmentல கலக்கிறதுனால தான். So in this process the lot of sulfur dioxide gets removed and it is very harmful to the environment. So in the modern metallurgy process the sulfur dioxide என்ன பண்றாங்க அதை trap பண்ணி அதை sulfuric acid என்ன பண்ணிடுறாங்க convert பண்ணிடுறாங்க in order to avoid the air pollution. Then next calcination. So this is also the process for converting the ore to the metal oxide, but in only one condition is differs from roasting is it is heated in the absence of air. Roasting மாதிரியே தான் இதுக்கும் heating கொடுக்கிறோம் below its melting point, but in the absence of air. But not always like that. Sometimes we need to give the limited supply of oxygen or some air. It is exclusively applied for the carbonate ores, for example cerussite, lead carbonate or calamine, zinc carbonate. So இந்த மாதிரி carbonate ores தான் calcinationக்கு யூஸ் பண்றோம். So we are using carbonate. அப்போ அதோட impurities என்னவா remove ஆகும்? It removes as a carbon dioxide. During the process, the water of crystallization present in the hydrated oxide escapes as moisture, which means இப்போ நம்ம எடுத்துக்கிற ஓரில் some water particlesum இருக்குன்னு வச்சுக்கோங்க. For example, here see in the hematite ore Fe2O3 along with that there is some water particles are there 3H2O அந்த ஓரோட சேர்ந்து கொஞ்சம் வெட்டா இருக்குது. அப்போ என்ன பண்றோம் calcinationல what we are doing we are just heating. அப்போ ஹீட் பண்ணல என்ன ஆகும் water it will get evaporate vapor ஆயிரும். So that is the dehydration. And also it removes the organic matter if present also get expelled behind a porous wall, which means இப்போ நம்ம எடுத்துக்கிற அந்த ஓரில் some of the organic matter means ஏதாவது decay ஆன some animals waste அந்த மாதிரிலாம் இருந்ததுன்னா that is also gets removed along with the heating. Heat பண்ணும்போது எல்லா impuritiesமே remove ஆயிடுது. Here this is the general equation. We are taking metal carbonates and we are heating in the absence of air. It gives metal oxide, then carbon dioxide evolves as a gas. So look at the equation. We have taken cerussite, PbCO3, then CaCO3, ZnCO3. இதெல்லாம் என்ன பண்றோம் heat பண்ணும்போது it converts into metal oxide. PbCO3 converts into lead oxide, PbO, along with the removal of carbon dioxide gas. Here the calcium carbonate. We are heating in the absence of air. It gives calcium oxide plus carbon dioxide. Here calcium oxide is nothing but a limestone. The CaO க்கு இன்னொரு நேம் என்னன்னா limestone. Then zinc carbonate it removes as zinc oxide, then carbon dioxide. So MgCO3.CaCO3 இதை எடுத்து ஹீட் பண்ணும்போது what we are getting MgO plus CaO plus 2CO2 that carbon dioxide removes as a impurities. So for dehydration, we have seen one example for dehydration. Along with the ore, if there is any water particles are present along with the ore, here when we are heating and the water it starts evaporates and separate the ore behind. So see the example for the dehydration process. Here the hematite ore Fe2O3.3H2O we are heating. So when we simply heating, the water particles get removed from its ore and we are getting the separate Fe2O3. Then one more example we have taken bauxite. Bauxite ore along with some water particles Al2O3.2H2O, and when we are simply calcinating means heating, when we are heating it removes the water particle H2O and leaving Al2O3 left behind. So this is the calcination. So in the first step conversion of ore into metal oxide we have seen roasting and calcination. Now we are going to see the second process, the reduction of metal oxide to its metal. இப்போ நமக்கு கிடைச்சிருக்க metal oxide என்ன பண்ண போறோம், we have to convert into its metal. அப்போ இதுக்கு நம்ம we are reducing the metal oxide to metal. We have seen in the first in the before slides we have seen by according to the thermodynamic principles metal oxide metal மாத்துறதுக்கு reduction பண்ணா it is very easier. That's why in the first process we are converting into the metal oxide. Here இப்போ metal oxide metal நம்ம மாத்தணும்னா we have to use some reducing agent in order to reduce into its metal. So what type of reducing agent we can use in this process are carbon monoxide, hydrogen, aluminum, and other some more reactive metals like sodium, potassium, phosphorus, etc. These are the reducing agents we can use to reduce the metal oxide into its crude metal. Here the choice of choosing the reducing agent, it is depends upon the nature of the metal. So எந்த மாதிரி metals எடுத்திருக்கோமோ based on that we can choose the reducing agent. For example, here carbon can't be used as a reducing agent for reactive metals like sodium, potassium, aluminum. So sodium, potassium, aluminum oda carbon vandu usually சேர்க்க கூடாது. Why? Because it may create some more very dangerous reaction. So that's why we can't use carbon as a reducing agent for sodium, potassium and aluminum, as well as for ZnO and Al2O3. For zinc oxide and bauxite ore, we can't use carbon monoxide. Carbon monoxide use பண்ணக்கூடாது as a reducing agent. I'll explain why we should not use some particular reducing agent for some particular ore. Why? Because the selection of the suitable reducing agent is depend upon the Ellingham diagram. So this Ellingham diagram we are going to see in the later session. So first let's see the reaction how it is reducing. But later on in the later classes I'll explain what is Ellingham diagram, and with the help of Ellingham diagram how to choose the reducing agent we'll be seeing in the later classes. So first reduction of metal oxide to metal. It can be done by the following methods like smelting, reduction by carbon, reduction by hydrogen, reduction by metal, and auto reduction. So by these process we can reduce the metal oxide into its metal. So first process is smelting. Here see the word smelting. Is remove பண்ணிட்டோம்னா என்னது melting, which means we have to melt the ore. அப்ப அந்த ஓர்ல உள்ள மெட்டலோட melting point அளவுக்கு நம்ம என்ன பண்ணணும், heat பண்ணணும். We have to melt the by giving heat we have to melt the metal. அப்ப என்ன பண்றோம், we have to heat above its melting point. This is the condition, major condition here. In roasting and calcination we will not heat above its melting point, only below the melting point we will heat. But in smelting process we have to heat at an elevated temperature, which means we have to heat the ore above its melting point in a smelting furnace. So here look at the picture here. This is the pictorial setup for the smelting furnace. அதாவது இந்த process வந்து அந்த furnace குள்ள நம்ம பண்றோம். So this is the picture here. And how we have to do this process? See, first process, metal oxide converts to metal with the help of a reducing agent like carbon monoxide or aluminum. Then நம்ம எப்பவுமே பார்த்திருக்கோம், along with the ore or metal oxide always there will be a impurities. அப்போ இந்த மெட்டல் ஆக்சைடோட சம் impurities will be there, gang particles will be there. அந்த gang particles எப்படி ரிமூவ் பண்றோம் அப்படின்னா we have to add flux to the gang, and in the reaction the flux creates the slag, which means, see here, flux means it's a chemical substance that forms an easily fusible slag with the gang, and slag means a waste material. இப்போ gang என்ன பண்றோம், ரிமூவ் பண்ணுவோம், impurities டைரக்டா ரிமூவ் ஆகாது, அதுக்கு ஒரு chemical substance called as flux-ன்றத நம்ம என்ன பண்றோம், கேங்கோட ஆட் பண்ணும்போது it reacts with the gang and removes as a solid waste material which is called as slag. Let us see with the example here. We have taken the hematite ore. இப்போ ore எடுத்துக்கிறோம், hematite ore with the in the hematite ore which metal we can extract? Iron metal we can extract. So now what we have to take, first metal oxide எடுத்துக்கணும், then along with that metal oxide gang will be there, which means impurities will be there. Then next reducing agent, metal oxide reduce பண்றதுக்குரிய reducing agent எடுத்துக்கணும், then gang remove பண்றதுக்கு flux எடுத்துக்கணும். So these are the four things we have to take in the reactant side. What are they? Metal oxide, gang, reducing agent, then flux. இப்போ this all we have to keep in the smelting furnace. Smelting furnace ல என்ன பண்றோம், we have to give a lot of heat. அந்த heat வந்து above its melting point விட ஜாஸ்தியான heat நம்ம கொடுக்கும்போது என்னாகும், it will separate the metal along with the slag. See here for hematite ore. Look at the equation here. Fe2O3 is the formula for hematite ore. Along with that, we have taken reducing agent carbon monoxide CO. Fe2O3 we have taken, then the reducing agent CO we have taken. இப்போ என்ன ஆகும், in the reducing agent it will reduce into its metal. அப்போ iron metal தனியாகவும் carbon dioxide செப்பரேட் ஆகும் வெளியேற்றிடுது. இப்போ மெட்டல் தனியாக நமக்கு கிடைச்சிருக்கு. இப்போ இந்த மெட்டல் ஆக்சைடோட some of the impurities will be there, gang particles. For example, இப்போ in most of the metals வந்து சிலிக்கா impurities will be there. அதாவது it is nothing but a dust வந்து யூஸ்வலாக எல்லா ஓர்லையுமே இருக்கும். if suppose in the hematite ore silica as a impurity, அது ஒரு gang impurity-ஆ இருந்ததுன்னா we have to add the flux. Here see the nature of the gang. Here the nature of the gang is acidic nature. இது வந்து acidic nature-ஆ இருந்ததுன்னா நம்ம யூஸ் பண்ணுற flux வந்து we have to take the basic nature. Here we have taken the flux as a calcium oxide which is also known as limestone. இது வந்து ஒரு basic nature உள்ள ஒரு flux. So if the gang is acidic nature, we have to take the flux as a basic nature, or else if suppose a gang is a basic nature இருந்ததுன்னா flux வந்து நம்ம acidic-ஆ எடுத்துக்கணும். So it will remove as a slag, as a separate impurities. Here see the picture here. We have they have in the top of the picture, see they have taken iron ore, coke and flux எடுத்துக்கறாங்க. They are pouring from the top of the furnaces, and see at the down of the furnaces they are giving the hot air கொடுத்து அந்த heat produce பண்றாங்க. அப்போ அந்த கோக் என்னாகும், அந்த ஹீட்டோட சேர்ந்து it will create lots of heat and will make the metals to melt. அப்போ மெட்டல் மெல்ட் ஆகும்போது அந்த டவுன் பார்ட் சி ஹாட் மெட்டலாக கீழே வந்து ஒரு லிக்விட் ஸ்டேஜில் it will form. Then அந்த impurities, அந்த gang impurities ஃப்ளக்ஸோடு சேர்ந்து another one layer, ஒரு smolten slag-ஆ ஃபார்ம் ஆகி slag we can separate it out and hot metal we can separate it later. So this is the process of smelting. It is very easy method. 4 things we are taking: metal oxide, along with some gang will be there, then reducing agent, along with that some flux. இதை எடுத்து என்ன பண்ணுறோம், we are keeping in the smelting furnace, and because of the heating first it starts separating the metal, then after that slags gets separated. So let us see with one more example. Extraction of copper from copper pyrite. Copper pyrite is a ore for copper. We are doing this in the reverberatory furnace. It is also a type of furnace which is used for heating. Here copper pyrite landa we are extracting the copper metal. So we have taken the ore copper pyrite. The formula is CuFeS2. So we are simply heating. So in presence of heat பண்ணும்போது in presence of oxygen we are heating. It gives 2FeS plus Cu2S plus SO2. இப்போ காப்பர் பைரைட்டில் சல்ஃபைட் பார்ட்டிகல் S இருக்கு. ஸோ இந்த சல்ஃபரும் இந்த ஆக்சிஜனும் சேர்ந்து சல்ஃபர் டை ஆக்சைடாக வெளியே போயிடும். தென் we are getting major product as FeS and Cu2S. In this, which one is our metal? ஐரனும் இருக்கு, காப்பரும் இருக்கு. பட் திஸ் இஸ் அ காப்பர் பைரைட். அதுதான் நம்மளோட ஓர் அப்படின்னா காப்பர் தான் நம்மளோட மெட்டல். அப்போ ஐரன் வந்து என்னவா இருக்கணும், இம்பியூரிட்டிஸாக இருக்கணும். ரைட். ஸோ FeS is the impurity, Cu2S is a metal which we have to extract now. Then sulfur dioxide is removed as in the first case. Then still we are heating. We have to heat above its melting point. But melting point விட அதிகமாக heat பண்ணனும்னா still we are giving a lot of heat. So still it reacts with the oxygen 3O2. Cu2S reacts with the oxygen. It gives Cu2O plus Cu2S. So in the Cu2S என்ன ஆகுது, it converts into its metal oxide Cu2O along with some unreacted Cu2S-உம் இருக்கு. இப்போ see in the another cases, for iron cases we take, still it reacts with the oxygen, it gives FeO. ஜென்ரலா எந்த மெட்டல் சல்ஃபைடோ இல்லை எந்த ஓருமே ஆக்சிஜனோட ரியாக்ட் ஆகும்போது மெட்டல் ஆக்சைடாக மாறும். ஸோ இங்கே காப்பர் என்ன ஆகுது, அதோட காப்பர் ஆக்சைடாக மாறுது. இங்கே ஐரன் வந்து அதோட ஐரன் ஆக்சைடாக மாறிடுச்சு. ஆனால் ஐரன் வந்து நம்மளை பொறுத்த வரைக்கும் இட் இஸ் அ கேங் பார்ட்டிகல், இட் இஸ் அ impurity. பட் காப்பர் ஆக்சைடு வந்து நமக்கு தேவையான மெட்டலை இதுலேருந்து தான் நம்ம எக்ஸ்ட்ராக்ட் பண்ண போகிறோம். Now see here, in copper oxide it reacts with some more excess இருக்கிற இந்த Cu2s ஓட ரியாக்ட் ஆகும்போது we are getting its metal 6Cu plus remaining all it removes as a sulfur dioxide SO2. Then look at the iron sulfide. Here iron sulfide reacts with oxygen, gives iron oxide FeO. This is nothing but a gang. But in the iron oxide வந்து it's the nature of its gang is basic nature. இப்போ basic nature na what type of flux we have to take? Acidic nature flux we have to take. So silica SiO2 we are taking as a flux in acidic nature. Acidic nature means we have to add some more acid ஊத்துனோம்னா அது acidic nature மாறிடும். So such a type of flux we are taking. So it reacts together and removes as a ferrous silicate. Ferrous silicate, it's a slag, it is just a waste particle. அதை எடுத்து வேற எதுவுமே பண்ணக்கூடாது. It's just a waste particle, we have to throw it out. So such a type of slag is forming. And down see, இங்கே காப்பர் ஆக்சைடு, அதோட மெட்டல் ஆக்சைடு என்ன ஆகுது, காப்பராக கன்வெர்ட் ஆகிடுது along with the sulfur dioxide removes as the impurities. Here this copper metal it is in the form of ஒரு liquid stateல இருக்கு. இப்போ ஒரு மெட்டலை வந்து ரொம்ப அதிகமாக மெல்ட் பண்ணோம் அப்படின்னா அது ஹார்டாக இருக்கும். We are giving lots of heat and we are making into a molten stage. அப்போ அது வந்து அப்படியே கொதிக்கிற மாதிரி பளபளன்ட்டு அந்த பபிள்ஸாக இருக்கும். ஸோ such type of copper we call it as a blistered copper. இங்கே இந்த காப்பரோட நேச்சர், அந்த ஃபிசிக்கல் நேச்சர் எப்படி இருக்கும் அப்படின்னா அந்த பபிள்ஸாக இருக்கும். பிகாஸ் there is a lot of sulfur dioxide gases getting evolved ஆகும்போது இந்த molten stageல வந்து ஒரு bubbles ஃபார்ம் ஆகிட்டே இருக்கும். That's why we call this copper as a blistered copper. So students, did you got some idea how this process happened in this smelting furnace? I hope you have understood this. Then next step, the second step for reduction is reducing the metal oxide into its metal by carbon. So we are using carbon as a reducing agent. இப்போ metal oxide ஓட carbon எடுக்கிறோம். carbonக்கு another name இருக்கு, coal, or else we can call it as a coke. So these we can call coke or coal or carbon as a reducing agent. Appo what it is happening, we have to give the heat and it converts into a metal along with the release of some carbon monoxide. Carbon reducing agent use பண்ணோம் அப்படின்னா நமக்கு என்ன கிடைக்கும், metal, then we get some carbon monoxide. Here this green arrow represent upper it face towards upper side, no, that represents it's a vapor, gas. அது வந்து கேஸாக ரிலீஸ் ஆகுதுன்னு அர்த்தம். ஸோ திஸ் ஆல்சோ வி ஆர் டூயிங் இன் த பிளாஸ்ட் ஃபர்னேஸ். திஸ் இஸ் ஆல்சோ அ டைப் ஆஃப் ஃபர்னேஸ் வி ஆர் டேக்கிங். இப்போ இந்த ஃபர்னேஸில் என்ன பண்ணியிருக்கோம், வி ஹவ் டேக்கன் மெட்டல் ஆக்சைட், ஜிங்க் ஆக்சைட். சி, வி ஹவ் டேக்கன் ஜிங்க் ஆக்சைட், தென் வி ஹவ் டேக்கன் கார்பன், சிம்ப்ளி சி, கார்பன் ஆர் கோல் ஆர் கோக் வி ஹவ் டேக்கன். Then it gets reduced into, because of this reducing agent, zinc oxide reduced into zinc. இந்த Zn வந்து தனியாகவும் இந்த ஆக்சிஜன் சியோட கம்பைன் ஆகி கார்பன் மோனாக்சைடாகவும் ரிலீஸ் ஆயிடுச்சு. பட் இட்ஸ் ஆல் டைப் ஆஃப் ஃபோர்ஸ் we can't take because there is some limitations are there. See, it can be applied to the metals which do not form carbides with the carbon at reduction temperature. நம்ம இதை ஹீட் பண்ணும்போது some of the metal oxide என்ன பண்ணும், கார்பனோட சேரும்போது it will form a carbide. நமக்கு இங்கே கார்பைட் ஃபார்ம் ஆகக்கூடாது, தனியாக நமக்கு மெட்டல் தான் வேணும். ஸோ such a type of metals only we have to take for the reduction by carbon. So did you understand? It should be applied to the metals which do not form carbides with the carbon at the reduction temperature. So such a type of metal oxides only we have to take for the reduction by carbon. So here one more example, Mn3O4 plus 4C. So it will separate into reduce into its metal Mn, manganese மட்டும் separate ஆகுது. Then 4CO evolves as a carbon monoxide gas. Then Cr2O3 plus 3C. இப்போ Cr is our metal and 3CO removes as a carbon monoxide gas. So it is very simple. Then next, reduction by hydrogen. Here it's very simple, same like a previous reduction. Metal oxide But here we are using reducing agent as a hydrogen. Then after the reaction we are getting metal. Then the impurities removes as a water. Carbon use panna carbon monoxide release ஆகும். Hydrogen use panna water release ஆகும். அவ்வளவுதான். சிம்பிளா ஞாபகம் வச்சுக்கோங்க. Carbon use panna carbon monoxide release ஆகும். And if you use if you use hydrogen, it removes as a water, H2O. And it is applied to the oxides of metal like iron, Fe, lead, Pb, or copper, Cu, Ag, silver, and nickel. So such type of metal oxide only we have to take for this process. And one more condition is it should be having a less electropositive character than the hydrogen. This is a major thing here. இப்போ நம்ம எடுத்துருக்க மெட்டல் ஆக்சைடோட ப்ராப்பர்ட்டி எப்படி இருக்கணும்னா it should be a less electropositive character than hydrogen. Electropositive characterனா என்ன? It means it's a less tendency to lose electron. இப்போ in all the metals elements will be having the electrons. இப்போ outermost shell உள்ள electrons always it will be tends to move away. அப்போ ஹைட்ரஜனுக்கு வந்து யூஸ்வலா it will be having more tendency to lose electron. அப்போ நம்ம எடுக்கிற போகிற மெட்டல் ஆக்சைடோட கேரக்டர் எப்படி அதோட எலக்ட்ரோபாசிட்டிவ் கேரக்டர் எப்படி இருக்கணும்னா it should be less tendency to lose electron than hydrogen. Such a type of metal oxide have to be used in this process. So in the fourth points, hydrogen has to be more tendency to lose electron and the metal oxide which we are going to take has to be less tendency to lose electron. See the example, Ag2O plus H2. H2 வந்துட்டாலே it has to remove H2O. அப்போ we are getting the separate metal 2Ag. Here this Ag having the less tendency to lose electron. And one more example, Fe3O4. It reacts with 4 moles of hydrogen. So H2O, it removes as 4 H2O water molecules. Then remaining 3 Fe is our metal. Then one more equation here, 2NiO plus CO plus H2. Actually this mixture of CO and H2, hydrogen and carbon monoxide mixture, we call it as a watery gas. So sometimes this type of reaction can also be occur. So we have taken metal oxide as a nickel oxide. Idoda we are taking a water gas CO plus H2. It gives nickel. Then CO use panale it has to remove as carbon dioxide. Then H2 means it has to remove as a water. So the last equation, can you get it how it is the products are coming? We are taking the metal oxide along with the water gas. Water gas means CO plus H2O. This mixture we call it as a water gas. As a product we are getting a nickel as a metal and evolving carbon dioxide and water as a separate impurities. Then the fourth process, reduction by metal. Here we have to reduce the metal oxide with one more metal. ஆல்ரெடி நம்மக்கிட்ட ஒரு மெட்டல் இருக்கு, அந்த மெட்டலை என்ன பண்ணியிருக்கோம், மெட்டல் ஆக்சைடாக கன்வெர்ட் பண்ணியிருக்கோம். அதை ரெடியூஸ் பண்ணி நம்ம தனியாக ஒரு மெட்டலாக பிரிக்கணும். பட் அதை பிரிக்கிறதுக்கு, அதை ரெடியூஸ் பண்ணுறதுக்கு we are using metal as the reducing agent. அப்போ நமக்கு என்ன கிடைக்கும், ஃபஸ்ட்டு மெட்டல் ஆக்சைடு என்னவா கன்வெர்ட் ஆகும், மெட்டலாக மாறிடும். அந்த ரெடியூசிங் ஏஜென்ட்டாக யூஸ் பண்ண மெட்டல் என்னவா கன்வெர்ட் ஆகிடும், ஒரு மெட்டல் ஆக்சைடு இம்ப்யூரிட்டியாக கன்வெர்ட் ஆகிடும். So you can make it out from the first equation. I have made a general equation. No, see the metal oxide plus metal. Here that metal is used as a reducing agent. Then it is undergoing the reduction process. So first this metal oxide converts into its metal. Then the second metal converts into the metal oxide impurity. Here the example is aluminothermic process. In aluminothermic process, here metal oxide can be reduced by aluminum metal as a reducing agent. Aluminum metal வச்சு ஒரு metal oxide reduce பண்றோம்னா அதுக்கு பேரு aluminothermic process. Here we have taken the ore Cr2O3. The Cr2O3 means நமக்கு என்ன metal கிடைக்கணும், chromium we have to get. So along with that we have taken aluminum metal as a powder form. இந்த powder formல எடுக்கிறோம் 2Al in the form of powder and we are heating. Heat பண்ணும்போது we are getting 2Cr as a metal and Al2O3 as a metal oxide. இந்த metal oxide வந்து it is a impurity. இது நமக்கு தேவையில்லை, but we got a metal 2Cr. This process has happened in the fire clay crucible. I have shown the picture of fire clay crucible. It's just a ஒரு ஹீட் பண்ணுறதுக்கு யூஸ் பண்ணுற ஒரு டைப் ஆஃப் ஒரு இன்ஸ்ட்ருமெண்ட் மாதிரி தான் இட்ஸ் பட் இட் ஹேவிங் த ரெசிஸ்டன்ட் ஹேவிங் ஹை ரெசிஸ்டன்ட் டு த டெம்பரேச்சர். எவ்வளோ ஹீட் பண்ணாலும் இதால் ரெசிஸ்ட் பண்ண முடியாது, இது வந்து பிரேக் ஆகவே ஆகாது. ஸோ சச் டைப் ஆஃப் ஃபயர் கிளே க்ரூசிபிள் வி ஹேவ் டு யூஸ் இன் திஸ் ப்ராசஸ். பிகாஸ் ஒரு மெட்டலே நம்ம வந்து மெட்டல் ஆக்சைடை நம்ம ரிமூவ் பண்ணுறதுக்கு மெட்டல் ஆக்சைடை நம்ம மெட்டலாக கன்வெர்ட் பண்ணுறதுக்கு இன்னொரு மெட்டல் யூஸ் பண்ணுறோம். அப்போ ரெண்டு மெட்டலை ஹீட் பண்ணுறோம் அப்படின்னா தெர் வில் பி a lot of temperatures will be coming out of this process. அப்போ அந்த ஹீட்டை தாங்குற அளவுக்கு உள்ள அந்த இன்ஸ்ட்ருமெண்ட் தான் ஃபயர் கிளே crucible. But in order to make this reaction happen, we have to use some other ஒரு ignition mixture யூஸ் பண்ணும். இக்னிஷன்னாலே என்ன, இட்ஸ் அ ஸ்பார்க்கிள். அந்த ரியாக்ஷனை just start பண்றதுக்கு we have to use some ignition mixture as barium oxide BaO2 plus Mg. It gives barium oxide MgO. இந்த ignition mixture ஓட யூஸ் என்னன்னா it will initiate the reduction process. ஸோ இந்த ஃபர்ஸ்ட் ப்ராசஸை இனிஷியேட் பண்ணுறதுக்கு ஜஸ்ட் இது ரெண்டையும் போட்டுட்டா உடனே நடந்துராது. the reaction will not happen at that time. When we add this ignition mixture to this first equation, it starts happening. See here, metal oxide, then we have taken aluminum powder, then ignition mixture in the fire clay crucible. Then as a product we are getting a metal separately, then Al2O3, BaO, MgO, these are all impurities is left behind, but we got the metal. So that first one was a general equation, and the second one is a major equation. Cr2O3 plus 2Al plus Mg plus BaO2 is the ignition mixture here. So these are all reacts in the fire clay crucible and removes chromium separately and remaining all as a impurities separately. Here why we have taken aluminum as a powder means it will facilitate the reduction process. Direct metal use பண்றதுக்கு பதிலா if we use in that powder form, it will facilitate the reaction. So as I said already, we are using fire clay crucible. Why? Because this reaction will release a lot of temperature, a lot of heat. So அதை withstand பண்றதுக்கு தான் we are using the fire clay crucible. So in this process there is a large amount of heat is evolved during the reaction. How much the temperature will be? It will be up to 2400 degree Celsius temperature will be evolved out during the reaction. And with the energy, enthalpy 852 kilojoule per mole. Enthalpy is nothing but an energy. So in the reaction nadakumbodhu, this metal along with the Al2O3, then BaO plus MgO along with this 2400 degree Celsius temperature will be evolved along with the energy 852 kilojoule per mole. So this is the reduction by metal. So active metals like sodium, potassium, calcium can also be used to reduce the metal oxide. So இதே processல நம்ம some other metal oxide also we can use. For example, B2O3 in presence of 6 moles of sodium. This is also sodium, magnesium, calcium. These are also reactive metals. So we have taken barium oxide, rubidium oxide, titanium oxide, thorium oxide along with the reducing agent. See, in the first barium oxide reacts with the sodium. It gives 2B plus 3Na2O. Here 2B is our metal and 3Na2 is a metal oxide. It is nothing but an impurity. Then rubidium oxide reacts with magnesium, gives rubidium plus magnesium oxide. Here rubidium is our metal. Titanium oxide plus 2Mg gives titanium plus magnesium oxide. Here titanium is our metal and magnesium oxide is the metal oxide impurity. Then fourth equation, thorium oxide in presence of 2 moles of calcium. We have to heat this around 1250 Kelvin temperature. It separates thorium and calcium oxide separately. So students, in this process, if you are using metal to convert metal oxide into its metal, there will be a lot of heat will be generated. This is very important here. Please remember it. And the next one, auto reduction. By the name itself you can guess. Auto reduction means it reducing on its own. Here the condition is we have to simply roast the some of the ores. It will gives its metal. See, இந்த நம்ம செகண்ட் ப்ராசஸில் நம்ம என்ன பார்த்துட்டு வரோம், மெட்டல் ஆக்சைடை எடுத்து என்ன பண்ணுறோம், ரெடியூசிங் ஏஜென்ட்டை யூஸ் பண்ணி அது ரெடியூஸ் ஆகி மெட்டலாக மாறுது. பட் ஹியர் வி ஆர் நாட் டேக்கிங் எனி மெட்டல் ஆக்சைடு, டைரக்ட்லி வி ஆர் டேக்கிங் த ஓர் எடுத்து ஜஸ்ட் ரோஸ்ட் பண்ணுறோம். ரோஸ்டிங்னாலே என்ன, வி ஹாவ் டு ஹீட் இன் த ப்ரெசன்ஸ் ஆஃப் ஏர். ஸோ நம்ம மெட்டல் ஒரு ஓர் எடுத்துக்கிறோம், வி ஆர் ஜஸ்ட் சிம்ப்ளி ரோஸ்டிங் மீன்ஸ் விச் வி ஆர் கிவிங் சிம்ப்ளி அ ஹீட்டிங் and in the presence of air டைரக்டா என்னவா மாறிடுது, மெட்டலா மாறிடுது. நம்ம ஆக்சிஜன் கொடுத்தாலே இது என்னவா மாறணும், மெட்டல் ஆக்சைடா மாறணும். பட் சம் ஆஃப் த மெட்டல் இட் will not convert into its metal oxide, but டைரக்டா அதோட மெட்டலே கொடுத்துரும். such a type is known as auto reduction, which means the ore is directly getting reduced into its metal. அந்த ஃபர்ஸ்ட் ப்ராசஸ்க்கு மாறாம மெட்டல் ஆக்சைடா மாறாம டைரக்டா மெட்டலை கொடுத்துருது. So here we have taken the example cinnabar. Cinnabaroட chemical formula is Hgs. From this we can extract the metal mercury. This is the ore for mercury metal Hgs cinnabar. Look at the equation here. We are taken Hgs in the solid form. We are simply roasting. Roasting means giving some oxygen in presence of heat. It's directly converted into its metal Hg with the removal of sulfur dioxide. So இங்க Hgs plus O2, இங்க Hg தனியா பிரிஞ்சிருது, then sulfur reacts with oxygen and evolves as a sulfur dioxide. It is very simple process, auto reduction. So these are the things we have seen today. See, let's review what we have seen in the today's class. First, extraction of metal. In extraction of metal, there is a two process. One is concentration of ore to metal oxide. Second, extraction of metal oxide to its metal. In first process, concentration of ore to metal oxide, it can be done by two methods. One is roasting, another one is calcination. Roasting means we have to heat in the presence of air. But in calcination, we have to heat but in the absence of air or else with the limited supply of air. Then in second process, extraction of metal oxide to its metal with the help of these five processes: smelting, reduction by carbon, reduction by hydrogen, reduction by metal and auto reduction. It is generally a reduction process. Second step ku extraction of metal oxide to metal nale we are using the reducing agent. In smelting, we have seen two terms, flux and slag. So melt pananum, which means we have to give heat, but we have to heat the metal oxide above its melting point. Melting point க்கு அதிகமா நம்ம ஹீட் பண்றோம். ஹீட் பண்ணும்போது it will reduce to its metal. Then அதுல உள்ள gang particles என்ன ஆகும், flux ஓட சேர்ந்து slag remove ஆயிரும். This is melting. Then reduction by carbon. So metal oxide reacts with the carbon. It gives metal with the, along with the carbon monoxide as a gas and it removes as an impurity. Then reduction by hydrogen. Here we are using hydrogen as a reducing agent. So metal oxide reacts with the hydrogen. It reduces to its metal along with the water. Then reduction by metal. Here we have seen aluminothermic process. So enna pandrom, we have taken Cr2O3 along with the metal aluminium in the powdered form. Then it removes its metalum, then metal oxide தனித்தனியா remove பண்ணிடுது. Here the metal oxide will be the impurity and the metal we can take for the further process. The next auto reduction. Auto reduction means here we are not taking the metal oxide, just directly we are taking the ore, and the ore enna pandrom, just simply we are roasting, means we are giving simply air and we are heating. It directly converts into its metal along with the removal of some volatile oxide. This is auto reduction. So these are the things we have seen today. Thank you.